I apologise for the quality of the video. All my kind of video stuff is in the UK, so I'm trying to do this on my iPhone piled on a bunch of boxes. But I really want to do a video on the new Rigol scope I just got, and I kind of specifically got it because the Rigol scopes have SPI Decode, which I don't have any on any of my other scopes. So although like the baseline specs of my other scopes are much better, they're I don't know, the one I have, the other one I have is like a quad 5 gigasample scope up to 500 megahertz. You know, they don't have SPI decode, and in particular, they don't have it. You know, if they do have it, they don't have it enabled, and I'd have to spend a lot of money on getting the SPI decode modules for these software licenses for these ancient scopes. So I figured I'd get the cheap the DS1054, which is pretty cheap. It's about $400. I was kind of a bit dubious because it's a 1 gigasample scope, and that's split between 4 channels, and for 100 megahertz bandwidth, that 250 megasamples per channel didn't seem like enough, but there we go. But actually, it's I've been really impressed. It actually feels really nice to use. It's a big step up from the other the low end kind of scopes that I've used. I previously used like a Handtech scope, and this is just miles ahead. It just feels quite nice to use actually. So so unlike a MSO, the Rigol does all of the decoding in software. So it captures analog signals and then runs it, I guess, through its step detection algorithm, and processes it as a decodes the protocol. So specifically what I wanted it for was looking at the interface to an SD card, and I've been trying to figure out why one piece of code isn't working and another piece of code is working, and it's some kind of funky timing thing. It was really nice doing this on a scope because I could see, when I've been setting this up, I can see what all of the traces look like. So I screw things up, like screw up the grounding, and you could see, oh, the traces don't look right, which was one advantage I felt this had over just capturing a digital trace. You can see if there's loads of noise, and if your signals you have signal integrity issues. So to set up the SPI capture, you do it's all in the math, which is odd, but it's math decode, and then you can select the serial signal type, and turn the decoder on here. You also have to select which channels the various signals are on, so clock and the data lines. And it's got this little button which lets you just switch the clock and data around if you've wired it up wrong, I guess, which is kind of interesting. So there are a few kind of gotchas. One is the mode, so you can put it in different modes. You put it in timeout mode or chip select mode, and timeout mode is not working for me, but I guess the idea is that it'll just wait for you to see no signal, just a stable signal, and no clock, I guess, for an amount of time, and then it will say, oh, okay, this is the start of a new packet. And you need that because there's no specific marker in the SPI signal that tells you this is the start of a packet, right? A start of a byte being transmitted over SPI. So you need something that tells you start the alignment here. So the easiest way to do that is put it in CS mode. And you can see if I don't have it in CS mode and I put it in timeout mode, it all just goes nuts, right? So these are whole packets, but because this is a fairly low frequency, it's always timing out, and it's going nuts. So I probably could increase that. We can try that. There we go. So if I increase that, the timeout is then long enough that it doesn't time out on the actual signal, and it just times out between the traces. But it's a lot. I found it in my case a lot easier if I wire up the chip select to channel 4, and you can do actually SPI without chip select, but it's kind of not a great thing to do perhaps. And then when the chip select fires, it'll start decoding a byte. One of the things I found a bit funky is this edge. Because it's got all the chip select stuff here, I assumed it was like the edge of the chip select, but it's not. This is the chip select rising or falling thing here, or CS, and it's the kind of just the logo kind of thing for it. It doesn't say edge or anything. The edge is actually the edge of the clock, I guess, that the data is read on. And it's this is configured for a mode 0 SPI transaction, so it's a rising edge. So that's what I found. I guess that's correct for mode 0. I mean, the nice thing about it is because it's doing it in software, you just get a capture, and you can just fiddle with all of the options until the signals look right. So you can see that this is wrong. I just know this is not what I'm sending, and then I can press it again, and it's like, oh, okay, now it looks right. The same is true as the byte order and the polarity. So this is the polarity. I guess this is positive polarity that is required for SPI mode 0. There's this threshold thing, and it has two modes of operation. One is auto thresholding, and one is static thresholds. Now, I can't remember where. You have to kind of configure it somewhere. Decode options. Yeah, so if you just press math, and then rather than going to any of the decodes, go to decode options, you've got this auto thresholding thing that you can turn on and off. And I chose to turn it off. It just, the reason being that if you do, it'll just move around. So it figures it out from the high and low level you see in the trace. And like, if a chip select was low, then it'll just screw up the threshold for the chip select or whatever, or if there's no input data, you'd screw up the levels because it would be trying to automatically detect it. So you can just set everything manually, and I just set them. This is 3.3 volt, and I just set them at 2 volts. That works fine. Okay, so that's all there is. You can obviously, I kind of recommend, so I've set the triggering on the chip select, and then it's kind of cool because of the way SPI works. You have to send a bunch of clocks without the chip select on. So I wanted to look at the start of a transaction, so I can just put it in single mode, and I just do like singles captures, and I capture until I see, oh, there are a bunch of clocks before the chip select activates, and I do it kind of zoomed out a bit, yeah, because I want my capture window to be fairly big. So if we do this, let's see if I'm actually producing any data. I may have screwed this up now. Let me see. Oops, yeah, that's not working. Is that not stopped working? Okay, so now my SPI device has crashed. So I can keep doing chip selects. Yeah, and I can keep doing it until I get the right thing. So this is the right thing, and there's a big pause at boot up, right? So my SPI thing is just continually cycling and booting up. So I'll put the capture like this, zoom out a bit, I'll see all these, all the clocks going through before a chip select, and I'll go, oh, okay, that's the start of my signal. And then I can just zoom in, and then you can zoom around the trace. And you can see the data. And this is another gotcha here, is that you can see as I'm moving around, I can go, okay, that looks great, that looks great. Oh, suddenly all my data disappears. So it's only decoding what is shown on the display. So I have to have the chip select pin, the chip select transition in the viewing kind of window. Otherwise, it doesn't work. So I think that's about it. Yeah, just to confirm that's actually working, you can see that it's sending a 40 is kind of the first, FF is just a wait kind of thing, and then it sends byte 40, and then if we go over and look at the code, you can see it's sending command 0, which is just a 0, and then if we actually look at the code, 4 card command, which is here, you can see that sends a 40, and then further down it's yeah, it sends the argument, which was 0, so 4 zeros followed by 95, which is all hex, of course. And then if we look at the trace, we can see just here 40, 4 zeros, 95, so I'm pretty confident that it's doing the SPI capture correctly. In terms of actually, tapping the signals, it's a bit of a mess. I ended up bodging, but you can't really see that very well, can you? The light. Ended up bodging a bunch of pins on top and just wire wrapping them through. I tried just hanging them off little wire wrap wires, but it just doesn't work. They just, because of the weight of the probes, it just pulls off the wires off the SD card slot. Probably I should design the board with test points actually. But there we go. Yeah, that's all I wanted to do, is just a quick video on SPI decoding.